Today we're going to be talking about a couple of new enhancements that we've recently shipped inside VMware Cloud and AWS. The latest of which is our M7i host type. Now, as we've already mentioned, M7i was a significant enhancement for us because we decoupled those boundaries between compute and storage and shipped a disaggregated host where you get compute resources and storage resources separately. Now, M7i is a latest generation host offered by EC2. It features an Intel Sapphire Rapids processor with a base clock of about 3.2 gigahertz, so it's very powerful. Turbo boosts all the way up to 3.8, so it's a real powerhouse for those hungry database workloads. It is a little bit smaller on the host size, though. It only has 384 gigabytes of usable memory. So, practically speaking, where we mainly see M7i being used in customer deployments is in smaller deployment use cases. Smaller clusters. This is more of an entry-level host. It's an incremental step before you get to the i4i host type or the 1 terabyte, the larger offerings. But when we take a look at environments with around 80 virtual machines and we do comparative sizings for a total cost of ownership, we see that M7i with FSx is about 20% cheaper for those workloads that fit within it. So it's a very powerful offering for us. For us, this is the beginning of the journey. We're not done with diskless host types and adding disaggregated host types, right? We're also not done with vSAN host types. We're here to offer a broad mix of instance compatibility to support all of the various different types of customer workloads. So with that out of the way, let's take a look at what this environment actually looks like. Today, what we're going to do is we're going to go through and deploy an SDDC and then fully provision the FSx storage and attach it, right? So this will be a complete end-to-end. This is everything the customer would need to do before they could start putting their virtual machines inside VMware Cloud and AWS, beginning those migrations, beginning consuming. So what we're going to do is we're going to start by deploying our SDDC through the VMware Cloud on AWS Cloud Console, right? The simple deployment wizard will give it a name for this SDDC. We'll pick the region that we would like to deploy within. We want a multi-host cluster because this is not a trial SDDC. And then we pick our host type. And here we're just going to select the M7i host type as our instance. If we take a look here, we can see that the UI is telling us that this is a diskless instance with no storage allocation. So when we're done deploying this SDDC, we'll have compute and memory, but not storage. Fast forward a little bit in interest of time, we acknowledge the charges and click deploy. Now in the real world, this takes about 2 hours to deploy. We don't have 2 hours here, so we sped it up in the interest of time, but we can see we've got our SDDC up and running. Now, if we go and we look, there is no storage attached to this SDDC. So now we need to get storage attached to it, right? Now, in truth, this is a 5-step process because we've got to do some networking constructs before we can just mount the data store, but it's not complicated at all. So we'll start by going through and deploying the FSx file system itself. This is done through the AWS console. So from the console, we'll go to FSx, we'll say create new file system, and then select the FSxfornetappontap ONTAP file system type. We're going to do a standard create and show you the full process this morning. We give the file system a name. And we're going to do a single AZ deployment this morning, and then we give it some SSD capacity. We'll just do about 9 terabytes. We'll leave everything else at default. Now, for the networking, we need to make sure that we're deploying this file system in the same availability zone as the SDDC itself, so that we don't have cross-AZ charges when we finish this networking connectivity. So we're just going to select the VPC that we want the FSx file system to be deployed within. And then we'll select the security group within that VPC that we want the file system to use. And then finally, we select our subnet. And again, this is the most important step. We need to make sure that we're deploying in the same exact subnet as the SDDC. We'll give this file system a password so that we have the ability to access it for all the advanced kind of integrations. If you want to use the Snap Center integration or DRO or anything like that, the ability to log in and manage FSx directly. We'll give our SVM a name just for identifiability reasons. And then just to be thorough, we'll put a password on the SVM again, just giving us the ability to log in either at the file system level or at the tenant level if we choose to use the file system for multiple different uses, right? You could have multiple SVMs. The security style does need to be set to Linux, and then we're just going to give this volume a descriptive name. And we'll give it 1 terabyte of capacity to start off with. We definitely want to make sure that we enable storage efficiency. And the snapshot policy, we'll leave it at default. In this case, you could customize it, of course. And then lastly, we've got our capacity pool tiering options. Now, our best practice for capacity pool tiering is to set this to none or snapshot only, right? But that's just a best practice. In reality, most customers leave this to auto and they just manage the capacity pool tiering to make sure that their primary capacity SSD pool has sufficient storage allocation to manage, the writes and can handle the ongoing workload. But if you look at our documentation, it does say use snapshot only. Finally, we'll configure the backups, and that's it. We've completely configured a data ONTAP file system. We've got this quick report that tells us what is permanent and what we can edit when we're done. We'll hit create. And in the real world, this takes about 30 minutes for the file system to fully deploy. Again, in the interest of time, we've sped it up, but we can see our file system is up and running. If we go in and take a look, here's our storage virtual machine, just as we asked for it. And then importantly, if we go to endpoints, we can see here the NFS IP address. This is the IP address that we will attach to the SDDC and we will mount the data store on, right? So now we need to connect this network, right? The 172.32.20 network to our SDDC network 10.2. And we'll do that using VPC peering. So now we hop back into the VMware Cloud on AWS console, and we go into our SDDC that we deployed earlier. We go back to that storage tab, and this time we're going to go down to VPC peering, and we're going to say create a peering connection. We just need 3 data fields here. We're going to give it a name, and then we put in the AWS account ID that the file system is deployed within. So this is where FSx resides, right? And then we put in the VPC ID that we deployed that FSx file system into the requester form. Hit create peering request, and in the background, we're going to go off and then initiate a VPC peering request from the VMware-owned account that the SDDC resides within to the customer-owned account where the FSx file system is currently connected. Once that's done running, we can see here it says approval pending, so we're ready to proceed to the next step. We go back into the AWS console, we'll go to VPC peering connections, and lo and behold, we've got a connection that is pending acceptance. So we're just going to come in here and we'll accept this request, connecting the peering connection between these 2 VPCs. Takes about 5-10 minutes for this to activate. Once it's active, we can then go back to the VMware Cloud on AWS Services console. And if we go back to the storage tab, you'll see that this sync VPC peering data task is running. And if we keep our eye on that approval pending, it clicks to active. Once this is done, the networking is configured so that the SDDC now knows how to get to FSx, right? So ESX can now mount that NFS mount point, but the FSx file system doesn't yet know how to get back to the SDDC. So the last step is to go finish the networking configuration so that we've got return routes that tell us how to get back into the SDDC environment from the customer account. And to do that, we just jump back into the AWS console. We go into the VPC that we deployed FSx inside, right? That shared services VPC that we picked at the very beginning of this process. We go to our security groups and we configure the security groups inbound rules for that VPC. And what we're going to do in this demo this morning is we're going to do a least privileges deployment. I'm just going to start coming through here. We'll start creating these rules. In practice, you could just open this up and say all allowed. It is a point-to-point connection. If you don't have it connected to any other network, it is fairly secure in and of itself. But a lot of customers, for rightful reasons, they want to make sure that they're least practice. So we need to come in here and create 5 rules: 1 for RPC, 1 for Mount D, 1 for the NFS server daemon, 1 for NLM, and 1 for NSM. And that's it, right? At this point, we have whitelisted and allowed listed all of the traffic to exit, the traffic to enter the VPC using the NFS ports that we're going to be actually sending traffic across. So now that we've allowed traffic to traverse this connection, the last step is to actually flip the route. So we'll go into the route table for that shared services VPC, We go into the routes, we're going to edit the routes here, and we're just going to add a route that says that the 10.2 network, right, our SDDC management CIDR, where those ESX hosts reside, is connected to a peering connection, ECX, this one. And that's it. So at this point, the networking has been fully configured, right? In the real world, it takes a couple hours just because you got to wait for steps to sync, and there are updates. But you can see the actual clicks and manual processes required are fairly simple. It's a light deployment guide if you wanted to write down exactly what you needed to do step by step. So the last thing that we need to do now is to actually attach the data store. And to do that, finally, we go back into the VMware Cloud on AWS console. We're going to go back to the storage tab. This time we're going to say add data store. And we're going to attach a third-party data store. We put in that NFS IP address that we got off the SVM endpoint report in the FSx Cloud console, and then we hit validate. And when we hit validate, the service actually goes out and it truly validates that NFS endpoint. It makes sure that it is an NFS server, that it has active mounts present, that we can actually connect to it. And only if all of that is true will it actually connect. So if you made a mistake, right, if you didn't whitelist your security group rules, if the traffic was being blocked by the firewall or something like that, you would find out about it right here at the validate step. If the validation passes, you have configured everything correctly and the environment is good to go. So now we just finished filling out the wizard. We'll select our mount point. We select FSx as the vendor, and then finally we put in a data store name. Now, at this point in time, data store names can't be modified once you create it. This is, we don't have rename support. It is a roadmap option or roadmap functionality for us. So just be careful when you're naming these to make sure that the name you give it is the one you want. And then we just click add and attach. And again, real world takes about 5 minutes for this attach process to operate. But after it's finished mounting, we can see in the Cloud Services console that the data store has been attached. And now if we log into vCenter, we've got our old friend, ESX. Everything works and operates just like it does on premises, right? That's the whole point. If we go over to the data store view, there's our data store. And lo and behold, 1 terabyte of usable capacity. And it's just that easy to actually connect these two services and consume workload. And again, the power here of decoupling these two, the independence of being able to size these environments independently. There was a long period of time where, if a customer had a petabyte of data, just the number of vSAN hosts that we would need, it was ludicrous. Nobody would ever use it, right? Those days are long since gone. And we've got plenty of customers that have compute footprints that are significantly lighter than their data footprint. And with the power of these two solutions combined, the solution is now a viable option for all of them.